Today we're going to be discussing chemical reactions. A chemical reaction is the process by which atoms or groups of atoms reorganize into different substances. Some of the clues that a chemical reaction has occurred are heat or light being produced, a formation of a gas, solid, or a liquid. You need to remember there is a difference between chemical changes, like what you see here with the rusting of the metal. Iron rusting is a chemical reaction versus a physical reaction like water freezing or ice melting. That is a physical change. It is still water, just in different states. There are 3 states to matter: solid, liquid, and gas. They can change forms, and that is a physical change or physical reaction. We use chemical equations in order to represent chemical reactions. The chemical formulas are things like H2O. Chemical formulas are a shorthand way of showing the numbers and types of atoms that are in a compound. Your chemical formulas are in a fixed ratio. When you change those numbers, then you change what the compound is that you have. A chemical equation is a way of showing how a chemical reaction has occurred. A chemical equation will describe how the atoms have taken and reorganized and what is produced. You will have a reaction, you will have an arrow to show that that reaction has occurred and the changes that have occurred after the reaction. So to the left, you see reactants, and to the right are the products. Reactants are the substances that you start with in a chemical reaction. Products are what comes after the chemical reaction occurs. So let's take a look at the parts of the chemical equation. The arrow means yields, produces, or makes. If you have a coefficient, those are the numbers that are in front of your compounds or your elements. They tell you the number of atoms, molecules, or units for those. They are large, they go in front of the compounds. Coefficients can be changed. Subscripts are the small numbers in a chemical formula. They are in a fixed ratio, and they tell you how many atoms of each type are in a compound. Subscripts cannot be changed when balancing your chemical equations. When we look at your chemical equations, we have to have the same number of each element on both sides. So if we have 6 atoms of carbon on the reactant side, then we need 6 atoms of carbon on the product side. This is the case because of what we call the law of conservation of mass. And the law of conservation of mass states that matter cannot be created or destroyed, meaning that the same atoms that are here have been here for millions of years, and those atoms just get recycled and reused throughout the ecosystems. The number of atoms on Earth, the number of atoms on the element's reactant side must be equal to the atoms on the number of the product side. This is called a balanced equation. So to wrap things up, atoms cannot be created or destroyed in chemical reactions. That is one of the most important things that you can remember, is atoms cannot be created or destroyed. They just get rearranged. When we are balancing chemical equations, you balance chemical equations by changing the coefficients, not the subscripts. You cannot change the subscripts, the little numbers that go below the line, because if you change the subscripts, then you change what compounds you have.